Hello all, welcome to the new lecture of second order linear homogeneous differential equations. In the preceding lectures, we were discussing about how to solve non-homogeneous differential equations of second order, linear differential equations of second order. And we have already stated that there are two methods for finding the particular solution of the non-homogeneous differential equation, and once we obtained a particular solution and the general solution of the homogeneous corresponding homogeneous equation, then we can find the general solution of the given non-homogeneous differential equation by simply adding the two solutions that we have already discussed. And there we already stated that there are two methods for finding the particular solution, known as method of undetermined coefficients and method of variation of parameter. Here we discuss in detail about the method of undetermined coefficients. So the method of undetermined coefficients is based on substituting the general form of a particular solution y of t into the differential equation a y double dash plus by dash plus cy equal to g of t, and then determining the specific form by forcing the assumed particular integral to be a solution. That means in this method we are first we have to identify what is the function g of t, and if the once we obtain the function g of t, we instead of taking g of t, we will consider the general form of g of t as a particular solution, and with undetermined coefficients, and we will find out the coefficients by substituting this solution into the given non-homogeneous equation. For example, if suppose g of t is given as some t square plus 1, that is which is a second order second degree polynomial, and we will consider for y of t the particular solution as we have to take the whole standard form of this equation with the coefficients, unknown coefficients. So the standard form is some a t square plus b t plus c. So instead of the given coefficients of t square, we taken an unknown coefficient capital A, and for the coefficient t as b, and instead of 1 the constant term, we have taken another coefficient, unknown coefficient is c. So we assume that the given integral differential equation has a particular solution of this form. Then this will satisfy the given equation, and then substituting y dash and y double dash in the given equation, we will obtain the unknown coefficients a, b and c. Then we will get the corresponding yt, particular solution of the given equation. Generally, we use this method only for non-homogeneous equations for which the homogeneous equation has constant coefficients. That means the functions multiplied with y double dash and y dash and y are constants like a, b, small b and small c. So this is applicable to only to those problems with the constant coefficients. Okay, in which the homogeneous equation has constant coefficients and the non-homogeneous term is restricted to, and g of t must be one of these functions like exponential function, polynomials and sines and cosine functions. That means if g of t is of the form some 2 e raised to t, then we will take y of t as some constant, another undetermined coefficient a into e raised to t. A e raised to t we will take like this, and then we will find out a by substituting in the given equation. Like this we have to we can do the undetermined coefficient method only for problems having g of t in the g of t as either exponential function or polynomials or sines and cosines or the combination of these functions. In the third point is if g of t in the equation ay double dash plus by dash plus cy equal to g of t is one of the functions in column 1 of the table below, choose the corresponding function yp in column 2 and determine the undetermined coefficients by substituting yp into equation 1. So in the below table we have classified the or we have stated the terms in gt, g of t and corresponding choice for the yp or particular solution. So that is our rule 1. So if g of t is one of these forms, then only we can choose this method for solving the non-homogeneous equation for finding the yp. If g of t is an exponential form, that is of the form k into some constant into e raised to pt, then the choice for y of t, the particular solution is some another constant capital A into e raised to pt, where a is the unknown coefficient constant, and that we will obtain or we can determine a by substituting y dash and y double dash in the given equation. Now, if the second g of t is of the form pn of t means polynomial of degree n, where n is equal to 0, 1, 2, 3, etc. So, if it is a second degree polynomial, we have to take y of t as the general form or standard form of the second degree polynomial. And if it is of third degree, then we will have four unknown coefficients. Suppose p3 of t is of the form 3t cube minus 1. Here actually the t square and t term are absent, but we have to take y of t as some a t cube plus b or a1 a cube t cube plus a2 t square plus some a1 t plus a naught, and we have to determine the four coefficients a3 a2 a1 and a naught by finding y dash and y double dash and then substitute all these in the given non-homogeneous equation 1. So in this way we have to take the functions for yp. And in the third case, if it is of the form k cos qt or k sin qt, if both of the functions or if the sum of these two or a combination of these two are given, then also the choice for yp is a cos qt plus b sin qt. Suppose g of t is of the form some 2 sin t, then we have to choose y of t not as a sin t itself, but we have to choose it as a sin t plus b cos t. This will be clear when we solve the problems. Okay, so first just to understand that just keep in mind that whether the g of t is either of the form k cos qt or k sin qt, we have to choose y of t as a cos qt plus b sin qt, even though the g of t contains at least one of sin or cos. Okay, now if the combination comes, that means a k e raised to pt cos qt or k e raised to pt sin qt, then we have to use y of t as e raised to pt a cos qt plus b sin qt. Now sometimes a polynomial into e raised to pt form will be there. Then we have to choose e raised to pt into the standard form of the polynomial. Now the combination of these three functions may arise. That is polynomial into e raised to pt into cos qt or with the sin qt. Then we have to choose e raised to pt into some a naught plus a1 t plus etc plus a n t raised to n cos qt plus e raised to pt sin qt into b naught plus b1 t plus etc plus bn t raised to n. So this is the general form for y of t in terms according to the functions that comes in the right side, that is g of t. So we have the main disadvantage of this method is that we can use this only for um, some particular type of functions like exponential function, polynomials, sine or cosine functions, or a combination of these three functions. Then only we can apply this method. And one more thing is that this is applicable for or it is easy to use this method only for equations whose homogeneous equation has constant coefficients. That means p of t, g of t are all must be constants. Now we will try to do the problems. Um, Find a particular solution of this equation. Here the right side function is an exponential function. So here the problem is to find the particular solution only. No need to find the general solution of equation 1. If we want to find the general solution, first we have to solve for the y1 and y2 of the corresponding homogeneous equation. But here the problem is to find particular solution only. So we concentrate on the g of t and do it by method of undetermined coefficients. So since g of t is equal to 3 e raised to 2t is an exponential function form. So when the g of t is exponential, we have to choose y of t as a into some constant into e raised to pt. Here p is equal to 2, that is given as 2t. So we have to take y of t as a into e raised to 2t. Then y dash t obviously 2a e raised to 2t, and y double dash of t is 4a e raised to 2t. Now substitute all these values in equation number 1. Then y of t, substituting this, we will have 4a minus 6a minus 4a e raised to 2t is equal to 3 e raised to 2t, or 6 minus 6a minus 3 into e raised to 2t is equal to 0, and we know that e raised to 2t is an exponential function, can never be 0. So this will become 0 only if minus 6a minus 3 equal to 0, or a equal to minus 1 by 2. Therefore, the particular solution is minus 1 by 2 e raised to 2t. So, if the equation has constant coefficients, in the left side all the coefficients are constant, and in the right side function is an exponential, that is in the form that we already listed. So y of t is very easy to find. The particular solution is very easy to find by the method of undetermined coefficients. Take y of t as some constant undetermined coefficient capital A into e raised to 2t, and that can be found by substituting this in the given equation. So we obtained the particular solution. Now consider the second problem. Find a particular solution of this y double dash minus 3y dash minus 4y equal to 2 sine t. Here also when you observe this given equation, we have the coefficients are here constants, and g of t is in the form sine t, is a function of sine t. Therefore, we can apply the undetermined coefficient method. Then so if the function is a sine t, function of sine or cos, we have to choose y of t as the full function a sine t plus b cos t, the linear combination of both. Be the particular solution, then find its derivative and the second derivative. Substitute this all in equation number 1. Then we can separate the coefficients of sine and cos as minus a plus 3b minus 4a into sine t plus minus b minus 3a minus 4b cos t is equal to 2 sine t. Now once we can, or we have minus 5a plus 3b into sine t minus 3a minus 5b into cos t equal to 2 sine t. Now equating the coefficients, we have the two equations in a and b, and uh, we make the one of the coefficients have the same, one of the constants have the same coefficient as b For b, we have made 15b in both equations. Then simplifying, we get a is equal to minus 5 by 17 and b as 3 by 17. Then we will get the particular solution as minus 5 by 17 sin t plus 3 by 17 cos t. Just substituting the value of a and b here. So, in this case, we have already discussed that when we listed the table, we have already told that even though the equation in the equation g of t is only a function of sine or cos, we have to take y of t in the full form. That is the linear combination of sine and cos. Then, we obtain A as minus 5 by 17 and B as 3 by 17. Therefore, the particular solution is A sin t plus B cos t. That is minus 5 by 17 sin t plus 3 by 17 cos t. And we have already told that if whether g of t is in function of sine or cosine only, we have to take y of t as the linear combination of both sine and cos, because when suppose if we choose y of t as a sine t only in this problem, then by substituting this in the given equation 1, we have 2 plus 5a into sine t plus 3a into cos t is equal to 0. Then we have this equation will hold only on an interval only if the coefficients 2 plus 5a and 3a are both 0. That is 2 plus 5a equal to 0 means a is equal to minus 2 by 5 and 3a equal to 0 will imply a equal to 0. That means this is impossible. Hence, by choosing on a y of t as only a sin t, we can't get the solution, or y of t will be a particular solution. For that, we have to choose y of t as a sin t plus b cos t. Next problem is find a particular solution of y double dash minus 3y dash minus 4y equal to 4t square minus 1. Here g of t is a second degree polynomial. So we have to choose y of t as a t square plus bt plus c. Then in the same way find y dash y double dash, then substitute in equation number 1. Then rearrange the coefficients. That is, separate the coefficients of t square, t and the constant term and equate with the right side with the functions that are on the coefficients on the right side. So t square, when we equate the coefficients on both sides, t square in the right side coefficient is 4 and in the left side it is minus 4a. So we will get a as minus 1. Then equating the coefficients of t. In the right side there is no term containing t, that is coefficient of t is 0. And in the left it is minus 6a plus 4b. So we have 6a plus 4b equal to 0 or 4b equal to minus 6a. From this we will get b as 3 by 2. Then equate the constant terms. In the right side constant term is minus 1 and equate it with the left side 2a minus 3b minus 4c. So we will get c as minus 3 by 2. Then the y of t is in this form. Minus t square plus 3 by 2t minus 3 by 2. Okay. Now the problem, we move to problem number 4, that is find the general solution of y double dash minus 3y dash minus 4y equal to minus 8 raised to t cos 2t. So in this problem we have to find the general solution of the given equation 1. For this we have to first find the general solution or complementary function or complementary solution of corresponding homogeneous equation. Then the general solution will be of the form C1y1 plus C2y2 plus yp of t, where set y1 y2 is a fundamental set of solution of the homogeneous equation y double dash minus 3y dash minus 4y equal to 0 and yp is the particular solution that is to be determined using the method of undetermined coefficients. So first we find the complementary function. We know that the homogeneous equation is a given equation with a constant coefficient. Then we know how to find the solution for this homogeneous equation with the constant coefficient. That is, first we have to write the characteristic equation, that is lambda square minus 3 lambda minus 4 equal to 0. Then factorizing that, we will get lambda, the values of lambda are 4 or minus 1. That means the two roots of the characteristic equation are real and distinct, lambda 1 and lambda 2. Then we have y1 of t equal to e raised to lambda 1t and y2 of t equal to e raised to lambda 2t. That is e raised to 4t and e raised to minus t. And when we calculate the Wronskian, we can see that the Wronskian is never 0. That means the set y1 and y2 will form a fundamental set of solutions, and consequently the complementary function or general solution of homogeneous equation will be of the form c1y1 plus c2y2, that is c1 e raised to 4t plus c2 e raised to minus t. Thus we have yc of t. Now we have to find the particular solution. So for finding the particular solution, we have to look upon the g of t, the function g of t. It is of the form minus 8 e raised to t cos 2t. That means it's a combination of exponential and cos trigonometric function. So in this, when g of t is in this form, the choice for yp is e raised to t a cos 2t plus b sin 2t. Then again find its derivative and the second derivative. Uh, which is in the reduced form yp dash of t is e raised to t minus 2a plus b sin 2t plus a plus 2b cos 2t, and yp double dash of t. Second derivative is e raised to t minus 3a plus 4b cos 2t minus 4a minus 3b into sin 2t. Substitute all these in equation number 1. Then and rearranging all the coefficients of sine and cos, we have 2a minus 10b sin 2t plus minus 10a minus 2b cos 2t equal to minus 8 into cos 2t. Then equating the coefficients and solving the two equations in a and b, we will get a as 10 by 13 and b as 2 by 13. So we will get the yp as this one. Then the general solution will be sum of these two solutions, complementary function plus particular integral or particular solution, yc plus yp. Hence we have the general solution of this is in this form. So in this way we can solve all the problems using the method of undetermined coefficients and solving the homogeneous equation. So for other, there are some more methods available. That means if g of t is the sum of any two functions, g1 of t as e raised to 2t and g2 of t as sum a cos t, sum 2 cos 3t in this form, then we have to apply some another rule, that is rule number 2 for finding undetermined coefficients using the method of undetermined coefficients, that we will discuss in the next lecture. So let's stop here. Thank you. Thank you all.